Hello, welcome. Episode number 27, Dynamic Mechanics tutorial on the motion along inclined plane. So a book of mass 0.8 kg is placed on a plane inclined at an angle of 30 degrees to the horizontal. We are to find the frictional force if the book, one, does not slide, two, did slide with an acceleration of what? 1.2 meter per second squared. So first of all, we need to make a sketch of the inclined plane and the position of the body. So let's see. Okay, so this shows the body. This is going to be the normal reaction. This is moving down as mg cos theta. This is the weight of the body. This is the frictional force moving in the opposite direction to the force pulling the object down, mg sine theta. The angle with the horizontal is 30. That makes that also what? 30. All right. So if the first one is asking for the body is still on the inclined plane, not moving. The reason why the body will not move, it means that the frictional force pulling the body away is equal to the force pulling the body down. So at that point, there is no greater force. So it keep on be at one place. If we can use two magnets, we can see the point whereby we put a neutral point, north and south, coming closer. There is a particular point whereby the object placed, they don't know whether to move towards the north or towards the south. At that point, the body is going to be still at a point. So here, if the body does not slide down, it means that the force, frictional force here is the same as the force moving down, mg sine what? Theta. That is the reason why the body will still remain at what? At rest. Or to say on the inclined plane. So by substitution, the frictional force here is going to be 0.8 times 10, the sine of the angle what? 30 degrees. This is going to be 8 times half of that. That will give us 4 Newton. So we can say that the frictional force holding the body still at its position is going to be 4.0 newtons. Then let's look at the second part. Now the second part says that the force, if the body did slide down, then the sliding of the body simply means that there is a particular net force pulling the body. So if the net force is pulling the body, it means that the force moving down outweigh the force pulling it away. Now it's like a tug of war. For the body to be able to come towards one direction, there should be a greater force from one side. So if those at the left have a greater force pulling, then the object at the middle will come towards where the force is. So we can say that the net force pulling the body is the mg sine theta minus what? The F. This is the frictional force. So the net force simply means that this is bigger than the frictional force. So whatever force, that the excess of that force, which is pulling the body, is the net force they're referring to. What causes the force to move? At the beginning, they were all having frictional force up and down in this form. So there should be a particular force that supersedes the frictional force. That is what you're looking for. But we can also say that the net force, as we're looking for, F, is ma. That's the mass of the body times its acceleration. So if that is clear, we can easily say that, let me rewrite this as ma equals to the mg sine theta minus what? F. But I think, what can I do? Let me bring in the force, which is the frictional force, to the left become positive. The mg sine theta will now be minus ma. Let's do our substitution as the mass of the body is 0.8. We can do an approximation, factorization. So I factorize that out. The force of gravity is 10. The sine of the angle is 30 minus the acceleration of the body, which we have as 1.2. So this means that sine 30 is what? Half. So half of this is 5. 5 minus this will be 3.8. Then multiply by 0.8 will give you, okay, let me still represent this so that I find the value in the bracket. Let's confirm whether it is 3.8. So that is actually 3.8. So now let's multiply the 3.8 and see with 0.8 and see the values will be 3.04. It's a force, so Newton. So we are only going to conclude by saying that the force, what force? The frictional force, which causes the body to move down as the body begins, not cause anyway, the frictional force as the body slide down is going to be 3.04 Newton. The one causing it not to move at all is going to be 4 Newton. I believe following from episode 24 down to this point, you begin to appreciate the use of the formulas we derived from the how do you call it? The introductory word episode. You are able to appreciate that. Don't forget to share, like, comment, subscribe, and come back as we continue to explore the formulas.